Good morning or good afternoon. Today we will be recording a video on Quizzette 824. As always, please make sure you write your last name, comma, first name, today's date, and your class color. Today I'll say I'm green. Number 1 says, is 2, 2 a solution to this system of equations? Yes or no? And they give you a system of equations, which I told you is when they give you more than one equation, you can say that's a system of equations. So remember when you write a coordinate, you write an x, comma, y. So if it's asking you if 2, 2 is a solution, you have to plug in x equals 2, in this case, because they told you x is equal to 2. And then you have to plug in y is equal to 2, because they told you y is equal to 2. And see if you get a true statement. If you don't get a true statement, then it's not a solution. So I'm going to pick the first equation, and then I'll do the second equation. So the first equation is 10x plus y equals 5. And remember, we're plugging in x equals 2 and y equals 2. So let's plug in x equals 2 right here, and let's plug in y equals 2 right here. So now I have 10 times 2 plus 2 equals 5. And we're trying to see if it's a solution, so that's why I put a question mark on top of the equal sign. 10 times 2 is 20. 20 plus 2, does that equal 5? Let's see, 20 plus 2 is 22. Does 22 equal 5? No, it doesn't. So automatically I can tell you that this is not a solution. We're still going to test the other one, the other equation they gave us, just to see if we have an example of a solution actually working. So the second equation is 2x plus 6y equals 16. And the same thing equals, like the same thing applies. X is equal to 2, y is equal to 2. So let's plug in x is equal to 2 for 2 times 2 plus 6 times 2 equals 16. And we're trying to test this solution. So that's why I put a question mark on top of the equal sign. 2 times 2 is 4. 6 times 2 is 12. That equals 16. Still a question mark until we get to the last step. Let's see, 4 plus 12 is 16. 16 does, in fact, equal 16. So the second equation, it does make it true. But the first equation is not. So therefore, is this solution a solution for the system of equations? And no, it's not. It's only a solution for one of them. So if you get two true statements, if you would have gotten like 5 is equal to 5 or 22 equals 22, then that would have been true for this one, and it would have been true for the second one, and then you would have circled yes. But since it's false for the first one, it's false for the entire thing. Number 2 says solve by using substitution. This is a little on the easier side because it did give you a system of equations, but the first equation is very simple. It tells you right away y is equal to 6. So literally they told you in your coordinate, x comma y, they told you that y is equal to 6. So you could already put 6 right there. And now you just need to find x. And the way you find x is you use one of the equations, plug it into the second one, solve for x. So in this case, I'm going to solve it into this second equation right here. That's the first equation. I'm going to plug it into the second equation. We have negative 7x plus 5y equals 2. And I'm going to plug in y equals 6 every time I see y. So let's write the new equation. Negative 7x plus 5 times 6 equals 2. Now we can solve for x. 5 times 6 is 30. Everything else stays the same. Just bring it down. And then I'm going to solve for negative 7x by subtracting both sides by 30. When I subtract both sides by 30, on my left, that's a 0 pair, and that cancels. And I'm left with negative 7x equals, remember, this is added together. And when you have a positive and a negative integer added together, you're actually subtracting them because they have different signs. So 30 minus 2 is 28. And then you keep the sign of the bigger number. And in this case, the bigger number is 30, and it's negative. So it's going to be negative 28. Now the last step is I want to get x by itself. So I'm going to divide both sides by negative 7. The reason I'm dividing both sides by negative 7 is because negative 7 is being multiplied right here. And the opposite of multiplying by negative 7 is dividing by negative 7. All right, so negative 7 divided by negative 7 is 1 whole, or 1x, but I just write x because the invisible number in front of every variable is 1 if there's no number visibly in front of it. Negative 7 goes into negative 28, 7, 14, 21, 28, 4 times. Remember, a negative divided by a negative is positive. So x is equal to 4. But that is not my final step. My final step is to put it as a coordinate or put it as a point. So up here, I'm going to fill in the blank. They already told me that y was 6. Now I found that x was 4. So my final answer is this up here. Parentheses 4, comma 6. It's a coordinate. And remember last week I taught you graphing, solving a system of equations by graphing? This right here, this point, would be their point at which they meet, or point of intersection. Make sure you're writing this down, please. So to visualize it, it would look like something like this, like in a graph. You don't have to write this graph. It would look something like this. And that point would be somewhere, oops, they actually meet over here. It would be somewhere over here. You do not have to write that. It's actually really messy, and I'm about to erase it. If it let me. Okay, it didn't let me. Whatever. Number 3. Number 3 is a sample of what I taught you last Friday, and you guys should have math notes on this. If you don't have math notes on this, you need to get that from a partner or ask me for my notebook, and I'll let you borrow it. So it says, graph these equations, and then I also want you to tell me the point of intersection. For every question of these, I want you to tell me the point of intersection. So it's going to be something like comma, a number, and another number, x and y. So point of intersection is going to be x and y, okay? This will be your final answer, but we're going to fill that in after. So with the first equation, my slope is negative 3 over 2. That means I'm going to go down 3, right 2. And then my y-intercept is going to be 0, comma, negative 5. And then my second equation, I'm going to write it in blue. My slope is negative 3 over 2. That means I'm going to go down negative 3 units, and I'm going to go right 2 units. And my y-intercept is going to be 0, comma, 10. Or positive 10. But I don't need to put positive in front of the 10. It's implied that it's positive. Now, if you notice something, both of these slopes are exactly the same. You're going to see what happens when you have slopes that are exactly the same. There's actually something kind of neat that happens. Let's start by graphing. So first things first, I'm going to do it in red. We have the first equation, and the y-intercept is at 0, comma, negative 5, and I put it on the graph. I don't know if you can see the red shading. I'm right here right now. I put the dot right here where my lightsaber is at. 0, comma, negative 5 is right there. Now I'm going to use a slope, and I'm going to go down 3, 1, 2, 3, and I'm going to go over 2, 1, 2. And that's going to be where my new point is. So again, I went to 0, comma, negative 5. There's 0, comma, negative 5. Now I'm going to use the slope, negative 3, right 2. So I'm going to go down 3, 1, 2, 3, right 2, 1, 2. So my new point is going to be right here in red. I'm going to write it. And now I can draw my line. I'm going to try my best to draw this straight. It's kind of hard on my iPad, but I'm going to do as best as I can.
Powering off.
Okay, thank you for ignoring that. All right, now my blue line is going to be at 0, comma, 10, which is up here. 0, comma, 10, and I'm going to go down 3, 1, 2, 3, over 2. So again, I use the slope. Down 3, 1, 2, 3, right 2, 1, 2. Now that I connect them, I have something that looks like this. This is what happens when you have the same exact slope. When you have the same exact slope, like negative 3 over 2 and negative 3 over 2, that means that you get parallel lines. This means they don't have a point of intersection. This means they will never meet, ever. So does this problem have a solution? It actually does not. So there are no solutions because the lines never intersect. Some of you are going to say, since it doesn't have a point of intersection, then I don't have to graph it and I don't have to show my work because I already know that they are not going to meet. You will get points for constructing the lines accurately. So don't skip out on it. Show your work, justify your reasoning.